So when we solve radical equations, the trick to doing this is undoing that square root, and we're going to undo that square root by squaring both sides of the equation. In order to do that, you have to have the square root all by itself on one side. All right? And if you look at example 1A, it is not. So that first step, and if you go back up here to your directions, it says isolate the radical on one side of the equation. We need to get rid of the 3. So subtract the 3 on both sides. And I have the square root of 2x minus 3 equals 5. Now that you've isolated the radical, doesn't matter what's on that other side. Now that you've isolated it, square both sides. So I'm going to put this in parentheses and square, and over here, square. Okay? So when I square a square root, those two things cancel each other out, and all I have left is 2x minus 3, and it equals 5 squared, which is 25. I am going to add 3 to both sides, and I have 2x equals 28. Divide both sides by 2, and that gives me x equals 14. Would you agree that's probably not too bad? That's not too bad. Now, the issue comes when the problems aren't as easy as this, and some of them aren't, and so when they're not, we need to go to some extra lengths. And one of the things that we're going to do is go over to the next page and take a look at example 4A. Now, do you see how we need to get rid of the 5, right? So we're going to add 5 to both sides, because we need, remember, you got to isolate the radical. Let's write it right here. Isolate the radical. That means the square root. So I'm going to add 5. But this is now not as easy as the last one. I've got the square root of x plus 7 equals x plus 5. Fair enough? Now that's not as easy as the last one, is it? Because now I have x on both sides. So now here's this. It works the same way. Once you isolate the radical, square both sides. So I'm going to put this in parentheses, and I'm going to square it, and I'm going to put this in parentheses, and I'm going to square it. Now, when I square this side, it's going to undo that radical sign, and this is going to give me x plus 7. You remember what you have to do on this side, right? FOIL. FOIL, 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 which is going to give you x squared plus 10x plus 25. We're going to FOIL that. Now, get everything on one side. We're going to go back to, this is now a quadratic equation, so how do we solve quadratic equations? Get everything on one side. So subtract x, subtract 7, and I've got 0 equals x squared plus 9x plus 18. Okay, what multiplies to 18 and adds to 9? Because now I got a factor. So I've got x plus 6, x plus 3. Okay, now set both of those, because zero product property, if this times this equals 0, then this is 0 or this is 0. So remember this, x plus 6 equals 0. X plus 3 equals 0 gives me x equals negative 6 and x equals negative 3. Now, you cannot stop there. You appear to have gotten 2 answers to this particular equation. However, I need to tell you, when you're doing this process of isolating the radical and squaring both sides, this creates what is called extraneous solutions, like crazy. All right? And let's go down here. Let's go all the way to the bottom and talk about extraneous solutions. Extra. All right, these are solutions that don't work. So they're not really solutions. But you still get them as an answer when you try and solve. So here's what you have to do to find out if either of these answers is an extraneous solution and therefore a bad answer. You've got to go back to your problem and plug them in and check them. So I'm going to do -6. So -6 plus 7 is 1, right? Square root of 1 is 1. 1 minus 5 is -4. And then I would have -6 over here. So you see how that doesn't work? I would have -4 equals -6. That's not going to work. I'm going to cross this baby out. That is not a solution. This guy right here is extraneous. Okay, let's try the other one. -3. -3 plus 7 is 4, right? Square root of 4 is 2. 2 minus 5 is -3, and on this side we have -3. That one worked. So this is your only solution. And when you're doing this, you are not going to know if you're going to have any extraneous solutions or not, unless you try them. Question?
Sort of. So extraneous solutions are solutions that don't.
They don't work.
Okay.
So they're not solutions, but you get them as part of the process of solving the equation, but they don't work.
Okay. Okay. At the bottom you wrote that they do work, so it's kind of confused.
There you go.
Okay. Thank you, sir.
Chris?
So it's like absolutely not possible for like if you get two answers for both of them to work, one of them has to be.
No. Could both work. Don't know. Have to try them.
Okay.
It's a crapshoot, but it happens a lot getting extraneous solutions, so you always have to check.
Okay.
Yes. Now, if we go over to the bottom of page 2, this is another kind of radical equation. Would you agree, when you're looking at this, this is essentially a radical equation because would you agree, this is a cube root right here, right? Okay. But it's not written as a radical. It's written as a rational expression. But it is radical. We're going to do the same basic thing, except we're going to kind of fiddle with it a little. What you're going to do instead of squaring both sides is you are going to raise both sides. There we go. There we go. Try to straighten it up. To the reciprocal power. So if you have x to the m over n equals k, raise each side of the equation to the power n over m, and this is the reciprocal. Okay? So first thing, we've got to isolate the part of our equation that is radical. So I want to divide both sides by 3. And I have x plus 1 to the 2/3 power equals 4. Now, I'm going to raise both sides to the reciprocal power. So put it in parentheses, and I'm going to raise it to the 3/2 power. Now, this whole process of doing this, these guys, when you multiply them, is 6/6, right? Which is 1. You'd agree, right? Cancels them out. So here's what I have. X plus 1 equals 4 to the 3/2 power. Let's start simplifying that. It's a square root, right? Do we know the square root of 4? Okay. Would you agree we can write it like this in radical form? And that the square root of 4 is 2, and that 2 to the 3rd power is 8. So I now have x plus 1 equals 8. Subtract 1 from both sides, and I get x equals 7. I've got one more example to show you, and this is kind of a long example, and this is an example that has 2 radicals in it. And sometimes when you're trying to solve radical equations, you have to go a couple of rounds to do this. So you see how I have 2 radicals here? Here's what I'm going to do. This one, to me, is more complicated, so I'm going to get this one by itself on one side, and I'm going to move this one to the other side with the 1. Okay? So I'm going to add the square root of x. And here's what I'll have. The square root of 2x plus 1 equals 1 plus the square root of x. Okay? Now, when I square both sides, I'm still going to have some square roots left out of this deal. So we're going to put both sides in parentheses, and I'm going to square them. Would you agree? The exponent that corresponds to a square root is 1/2, right? What's the reciprocal of 1/2? Which is what you're doing to it. Okay, so here's what we've got. The squaring and the square root cancel each other out, and I get 2x plus 1 equals, and over here I have to FOIL. So this is going to be 1 plus 2 square roots of x plus the square root of x squared. Agree? All I've done is FOIL. And this is x. Okay? Now here's what you got to do. You have to get the radical all by itself, and we got to go again. Because now you're down to 1 radical, so you need to get that by itself. So I'm going to subtract the x. I'm going to subtract the 1. And I'm going to have x equals 2 square roots of x, right? We're going to square it again, yeah. But here's what I'm going to do. I want to get the square root by itself, so I'm just going to divide both sides by 2. And that is going to give me x over 2 equals the square root of x. Now I'm going to square both sides. And I've got x squared over 4 equals x. So far, so good?
And you multiply by 4?
Yeah, because I don't want a fraction, so I'm going to get rid of it. So here's what I've got. X squared equals 4x. You've got an x squared term. This is quadratic. Get everything on one side.
Oh. I thought you could just square root both sides.
Yeah.
Oh, you couldn't.
No, you
If I did
can't.
4x.
Because you have an x.
Oh.
That would give you what you just had. So x squared minus 4x equals 0. Factor. How can you factor this?
X.
Take out an x, and it leaves you with x minus 4. Okay? You had a greatest common factor there. So what are your solutions? X equals 0.
Or x equals 4.
X equals 4. Now, you got to go through this extraneous solution business again. So let's go back to the original equation and try 0. So if we put a 0 in here for x, this is 1. Square root of 1 is 1, minus the square root of 0, which is 0, gives us 1, and that one works. So we're going to circle that beauty right there because that works. Let's try 4. 2 times 4 is 8, plus 1 is 9. Square root of 9 is 3. 3 minus the square root of 4, which is 2. 3 minus 2 gives us 1. That also works. So we have 2 solutions, no extraneous solutions.